data. Okay, so this time the input images, the input files are images of satellite. These are satellite images of Kolkata. The images, there are 4 images that are provided in the assignment. You just have to load the data, and all the steps are actually mentioned in the PDF. Okay, follow those steps. Those steps are very similar to what you have already done. Also, you have calculated the covariance matrix, I think, in the for second class. So that will also help here. You have to calculate the covariance matrix and the Bayesian probability for 2 classes. There are actually 2 classes in the image. One is for river class and one is for non-river class. So you have to assign the pixels, or randomly you have to select random pixels and classify them to either river class or non-river class based on the Bayesian probability. Okay. Go through the assignment. All the steps are very clear, and like mentioned, if you have any doubt, you can ask.
Ma'am, ma'am,
Yeah. Yeah.
ma'am, the pictures that you have given are not in 512 to 512 resolution.
Yeah. There are some like padding done in like around the images, so you have to crop it and make
Okay.
it 512 cross 512.
But the actual images was 512 512, na Joita?
Yes, sir. But the images that I have that are padded with white space, so they have to crop the image first.
No. So I'm having this actual images. Okay. So I'm just
Okay.
sharing. Okay. Otherwise, so means how they will do it.
Uh, okay, sir. I have already uploaded the images in the assignment. Can you upload? Like I'll delete those images and you can upload the new
Okay.
images. Okay.
Because the images that you have, I think it is a contrast enhanced images.
Please wait for some time. Sir will upload all the images. Then you can start.
So you see the link. Okay. So this is from the ISI Kolkata. So at the below you will see that Calcutta images, band 1, band 2, band 3, and band 4. You just download it from there. Okay. Did you get it?
Sir, those are GIF format, sir. It is also applicable.
Yes, it is in zip image. What is the big deal?
Okay,
Zip
sir. Okay.
image, PNG image, JPEG image, both are same.
Okay, sir. Okay.
Okay, only you'll have to give the extension name. You save it as a other format now. Okay, and you'll see that there's a format is 512 into 512.
Okay, sir. Okay.
Okay, you checked it and tell me the size of the image. Okay.
Sizes are, sir, 512 cross 512 only.
512 into 512, na?
Yes, sir.
Okay.
Hello, ma'am.
Yes.
So I'm not getting what are those two classes. It says river and non-river. So how can we get the sample points for those two classes from the image?
Yes, you have to select the pixels from the images to create those class. Like you have to pick the pixel points that belongs to um, the image, and I think there are some examples already in the PDF. You can see there are some examples in the PDF also. You can use that, or you can select your own points to define the river and non-river classes. You have to do it manually. Okay.
So we have to do it manually, like drag
Yeah.
those points and type it
Yeah.
manually. Like.
Yes.
Hello, ma'am.
Yes.
So what we are gonna do is like define some x coordinate and y coordinate for river class, which will be same in all the four images, and take the corresponding pixel values.
Yes.
Okay, so in the image, it looks like there's one river is there. Is it related to that somehow, or?
Yeah, in the image you can see the river. You can see the river, right?
Yeah.
It's the Ganges. So pick one of, like, select pixels from the river and put that in the that X chord river and Y chord river.
So
Okay.
how can we extract that coordinates from image for that particular, like, is it belonging to that river or not?
How can you? You can browse the image in the, if you open the image in MS Paint, or like any image tool that you are using. Okay, so there are options to visit the, like, know the what are the pixel point, exact point. What is the pixel value? If you open it in MS Paint.
Okay, so 50 samples.
Yeah.
Okay, ma'am, I'll just go through it once and ask if
Yeah,
there's.
yes. The selecting the pixel point. I'm just telling you that you have to do it manually. Okay, so either you can take the some of the points you can take from the PDF. It's already mentioned, and for other points you can open. Like if you are using MS Paint, then you can get the pixel point. Like whenever you hover your mouse, it will show you the pixel point. If you, and in other image tool also this options are available. Okay, from that you have to select the x and y values for the river and non-river classes.
Ma'am,
So ma'am, we have to take 50 points manually only.
Yeah, you have to take manually.
Okay, ma'am.
50 for each band. That is total for river class would be 200, right?
No,
So
for
like,
all bands the pixel position is same.
okay. So 50 only.
Yes.
Corresponding pixel value will change for all the bands though.
Yes, but the position will be same.
Yes, ma'am, got it.
ma'am. So,
Yes.
so basically we are keeping both river class and non-river class equiprobable, right?
Hmm.
Okay, ma'am.
Both the classes are equiprobable.
Yeah, you have to take 50 points from both the classes.
It says 100 sample point from non-river class.
Uh, which line? Okay, yeah. 100 sample points for non-river class. So it's not equiprobable.
Yes.
Hello.
Yes, sir.
Let me make it clear to you. Equiprobable does not mean that equal samples that you are going to take. Okay. Equiprobable means if your prior probabilities that you are going to fix, okay, it is 0.5 and 0.5, then you can say both the classes are equiprobable.
Yes, sir. But for the prior probability, we calculated that number of sample points out of all the samples.
Exactly. Yeah. Because
So,
the number of sample points, if you mix up both the samples, and from both the samples you could take 50%. I mean this 50 samples divided by total number of samples from one class, and the 50 samples from the other class divided by total number of samples. Then it is the equiprobable class.
yes, sir. Yes.
Okay. But here I'm not telling you that 50 samples you can take from river class, and also 50 sample you can also take from the non-river class. So there is no harm. Okay, but
Yeah.
the example that is given to you, you can have more number of samples. So it is not a kind of restriction that only 50 samples you need to only collect.
Okay, sir. Yeah, so you can take any number of sample points, but it should be, I guess, minimum 50 and 100 that are mentioned here. So, sir said it's not that it should be fixed that this number of sample points you have to take.
Ma'am, and there are given three cases where prior probabilities are 50-50 and one case where prior probability of river class is 0.7 while other is 3 and reciprocal. So we have to calculate for all the three cases, right?
Yeah. You have to calculate it for all the three cases.
Okay, ma'am.
So accordingly, the number of samples we select for each class will change, right? When it's 50-50, we have to select the equal number of sample points for training.
No, I guess here the prior probability is because it's already defined that you have to take these cases. So you don't have to calculate the probability from the sample. But when the prior probability is not given, then it generally happens that we have to calculate from the number of sample points. So, but here it is
Here
given,
it is
so you can
given,
use
so
that.
okay.
Ma'am,
Yes.
ma'am, in step number 8, uh, what will be dimension of test data? I mean,
Step number 8. Okay. Yeah.
ma'am, in test data, we are let's say we are taking R band, G band, B band, and I band values. Only one pixel. Let's say starting pixel value. Test data for I equals to 1, it will be 1 cross 4, right? Minus the mean of previous T1, which is also 1 cross 4. So this overall will be 1 cross 4.
I did not understand. Like,
Ma'am, what will be the dimension of step number 8, test data minus T1?
okay, you are asking what? Okay. So for river class, right? So it will be 4 cross 4. Yeah.
No, not 4 cross 4. It will be
Uh,
1 cross 4.
No, the covariance matrix would be 4 cross 4 and its inverse. Yeah, it would be 1 cross 4. But if you are using like, because you have to calculate for all the data at once, right? It won't be like that 1 pixel and 4 dimensions. No, not like that. So you will have this 2 cross 512. That would be the row dimension.
And
Cross.
then how we will be calculate the river class under this multiplied, right? In step number 8, it is saying test data minus T1 transpose into inverse of covariance. Then we won't be able to multiply them.
No, it would be 512 into 512, whatever it comes on the.
And then what will be the dimension of inverse of covariance reverse?
Yeah, it would be 4 cross 4, but the dimension of test data minus T1, it would be 512 cross 512 cross 4. Like 512 cross 512 would be the number of rows. Yeah, it would be 4. Then the final one would be, and the test data okay. Yeah, so after the inverse, there is also multiplication for test data minus T1. That is 4 cross 512 cross 512. So the river cross should be 512 cross 512 in a row and 512 cross 512 in the number of columns. Should be like that.
So, ma'am, in the end, river class will have 512 into 512.
Yes. Wait. Wait, I just confirm it. Okay. Once.
Okay.
Okay, so if you are taking one pixel at a time, then the dimension would be 1 cross 1. Okay, and if you are taking all the 5 cross 5 1 2,
Ma'am,
that
1
is
cross 4.
no 1 cross 1.
Okay.
Okay, because the covariant matrix is 4 cross 4. The first one is 1 cross 4, then into 4 cross 4, then 4 cross 1. Okay, so it becomes 1 cross 1 if you are taking one pixel at a time. But if you are taking all the pixels, that means that 512 cross 512, that is 2,62,144, then that many number of rows and that many number of columns if you are doing it like simultaneously for
Yes.
all the
Ma'am, but
pixels.
in the formula, it's given test data minus T1 to whole transpose. Then this transpose will cause 1 cross 4 to 4 cross 1, right?
Yeah, 1 4 cross 1 to 1 cross 4.
4 cross 1. I mean, ma'am, I am taking a array of 4 size 4, where first one will be first pixel will be of R band, then G band, then B band, then I band.
See, the covariance matrix is 4 cross 4, right?
Mm-hmm.
You have to adjust your data likewise. So you have to make it 1 cross 4. The for the test data minus T1, that transpose, that is 1 cross 4. So according to that, the test data minus T1 should be 4 cross 1. Right?
Ma'am, if no, wait, if test data is 1 cross 4, T1 is 1 cross 4, then when we separate it, then output will be 1 cross 4, right? Not 4 cross 1.
What is the dimension of your test data?
Ma'am, 1 cross 4.
1 cross 4.
Hmm. And my mean vector will also be 1 cross 4.
Then
T1.
if you have the test data as 1 cross 4, then don't do the transpose in the first one. Like you can do it the test data minus T1 cross then the inverse, covariance inverse, and then the test data. Because if you
Test data minus T1
present
to
it,
transpose.
it mean like that is actually up to your representation of data. If you want to keep the vector as like the column vectors as 1 cross 4, then that is fine. But in when the x is represented, that is actually generally represented as the number of dimensions. Okay, as a single vector, it is not presented row wise, it's generally presented column wise. Okay, when one single pixel is represented, that's why like the transformation is happening. So it is up to you that like how you're presenting, like you're taking your vector dimension. But the covariance matrix should be 4 cross 4.
Okay, thank you.
Hello, ma'am.
So we are getting some noise.
Hello.
Sasikant,
Yes, ma'am. Yes, sir. I'm supposed to ask.
we are getting some bad noise. So can you just okay now it's okay.
Yes, sir.
Okay, you just ask to the okay. Okay, good for answer.
Okay, so ma'am, how we can, which package we will use to show output image?
Which package? You can use the matplotlib only,
Ma'am,
you can yes.
then we will plot a graph with matplot because it is showing a image, output image.
I think it would be better to like instead of matplotlib, you can just show the image with the pixels that you are like classifying with two different colors and show it as an image. Better than plot.
Ma'am, I have used OpenCV.
Yeah, you can like use any thing to show the image instead of plot.
Okay, ma'am.
Ma'am,
Yes.
ma'am, after the steps, we are using the multivariate normal distribution, right? For classifying class 1 or class 2.
Yeah.
Ma'am, in this formula, in multivariate normal distribution in question, it's given 1 upon root 2 pi to the power capital M. Now, what is capital M?
Wait. It's a number of dimensions, I guess.
Then, ma'am, it should be 512.
Yeah,
Four.
like in the multivariate normal distribution, this is the formula is given for you to know, but uh, the calculations that are required are already mentioned in the previous steps. So here that minus 0.5, that is what it no, sorry, actually for this one the denominator part is not required because for both the classes it will be same, so that's why it is not being calculated.
Oh,
Okay.
but we have to calculate the determinant, root of determinant.
Yeah.
Determinant of that covariance.
The covariance matrix, yes.
Okay,
But it will
okay.
be same for that constant, so that's why not.
Okay, then ma'am, from the formula we can omit minus 0.5.
No, that minus 0.5 is within that exponential. Okay, but root 2 pi to the power,
No,
I
ma'am,
guess.
ma'am, in this exponential, in the step number 10, in the formula, exponential in river class, and when we get in the river class in step number 8, there is not point. Yes,
Yeah,
ma'am.
yes. In the step number 8, what?
In step number 8, there should be multiplication of minus 0.5. I mean, in step number 8, river class equals to minus 0.5 into test data and the whole.
No.
Ma'am, but if you see the formula.
Okay, you're saying that, okay, in the exponential, there minus half is there, x minus, yeah, it should be there. I have to check. So,
Actually, Joyita, there is a problem. The minus up will be in the XP of minus up. Okay. I mean, 0.5 will not come over the outside. It should be.
yeah, it should be within the exponential.
Exactly. Yes, sir. So there is a mistake. I already told them in the class itself. No.
Oh, okay.
Okay.
So the minus 0.5 is the should be within the exponential.
Yes.
Sir, what is like that? I forgot. What does this m represent in the fx equal to root over 2 pi to the power
It's
m?
a dimension.
Is it number or dimension? Okay, yes. So that is the number of dimension, but you can.
Ma'am, here what will be the number of dimension?
It will be cancelled out, na?
Yes. For
It will be cancelled out from both the side.
Yes. Yes. Here the number of dimensions are 4 because you're taking 4 bands.
Exactly.
Oh,
correct.
Hello, hello, ma'am.
Yes, yes.
Ma'am, yes, ma'am. Actually, ma'am, in the link, sir has given 4 images. Those are named as band 1, 2, 3, 4. Actually, which band representing which?
RVGI. Okay.
Sorry, sir.
Red, blue, green, infrared.
Okay, sir.
Band 1 for red, band 2 for green, band 3 for blue, band 4 for infrared. Okay.
Yes, sir.
Excuse me, ma'am.
Yes.
Ma'am, I have plotted the output image, but it's not coming as in the question. If you could look at my code.
Okay. Wait. Aditya, right?
Yes, sir.
Okay.
Hello. Hello, ma'am.
Yes.
Can we leave?
Yeah, but there is some noise from your side. Can you adjust the phone or something? Yeah. Uh,
Is it okay, ma'am?
okay. Yeah, I can ask a question.
Ma'am, I don't have any question. I am saying, can we leave this meeting?
Hey, why?
You explained the assignment. We are just connect.
No, you can't because I haven't taken that attendance yet. That is the one question. And also the lab is still 5. So we have